this is a question about resistance, more importantly, current voltage graphs. So we have an electrical component here, and we need to determine the current voltage characteristics of this component. So the circuit that can be used can be a very straightforward circuit like the one you used yourselves to find the current voltage characteristics of a bulb and a simple resistor. Okay, if you remember, your circuits look like this. You have a power supply, you have a variable resistor so that you can vary the current, you have an ammeter to measure the current, and a voltmeter across the component so that you can register the potential difference across the component as you change this current. And this is what the voltage current, or the current voltage, I should say, characteristics look like for this component X. As you can see, it's not a straight line, so therefore Ohm's law is not being followed. But before we get to that, let's answer these two questions. Use the graph to determine the current in component X. Well, it's connected across the terminals of a battery of 6 volts of negligible internal resistance. Okay, so if we had to draw that circuit, it would look a little bit like this. You would have a cell, a component X, like that, and nothing else. And what's important about this is it shows that if you have 6 volts EMF, then because the energy in equals the energy out, then you would have 6 volts across this component X here. So if the EMF is 6, then 6 volts are across here. So we can just use the graph. It says use the graph to determine the current. So if we find the voltage 6, at that point, when the voltage is 6, the current is 4 amps. And I should stick to the decimal places in the table, so I don't really need that. Now, the second part of the question is to work out the resistance. Resistance is voltage over current. We have voltage of 6 volts and a current of 4. So 6 over 4 equals 1.5 ohms. Okay, so now a change of situation. The resistor R of constant resistance 2 ohms is now connected in series with component X as shown below. And it asks, on the graph opposite, draw the IV characteristics for the resistor R. Now, with this program, I can't zoom back to look at the graph, so I'm going to have to draw it here. So what would this graph look like? Well, let's have a look at the information they give us. The resistance is 2 ohms. And what's resistance equal to? Resistance is equal to voltage over current. So the ratio of voltage to current is always going to be 2. Now what we need to do is plot a graph. So we need some coordinates. So if I write voltage and current, okay, maybe I can get some. Let's have a look. On the y-axis we have I, current, and on the x-axis we have voltage. Now let's have a look. If our current is equal to, say, 2, then our voltage would have to be equal to 4 in order for the resistance to equal 2, because 4 over 2 equals 2. So that's our first coordinate. And if we carry on with that, what happens if our current is 3? Well, then the voltage must be 6 in order to give us a resistance of 2. So the voltage is 6 and current is 3. So you would then, on your graph, plot those points. So you have current 2 and voltage 4. And then you would have current 3 and voltage 6. Okay, you should have a nice straight line going through the origin. Why is it a nice straight line? kind of messed that up, didn't I? Got a nice straight line because the resistance is constant. And remember that 1 over the gradient is equal to resistance. In comparison to the other line, what you should end up with is the curved line above. And this should go through the origin. It's just a bit of a mess. Okay, and the last question. Determine the total potential difference, E, that must be applied across component X and R such that the current through X and R is 3. Okay, now we can use the graph for that because we have exactly that information. So if I just sketch it there, though there's no meeting, let me just rub that off because they don't meet. Okay, so in order for the current through both to be 3, okay, let's have a look. You use the graph, you find the value of current, which is equal to 3, and it will give you two values. It will give you value for component X. You'll go down here, and that will be equal to a potential difference of approximately 3.7. And then you carry on at 3, and you should find your resistor has a value of 6. So that means to keep that current flowing, you would need 3.7 here and 6 here. So that gives a total of 3.7 plus 6, which is 9.7 volts.